Hi, this is part 2 of the Remote Pilotage mini-series here in the Maritime Innovation Update. My name is Jonathan Weisheit. Welcome to today's session. Before we get started, I would like to stress the fact that this session is being recorded, and by participating in this event, you're accepting the terms of use. Please keep your cameras off and your microphone muted. If you have any questions throughout the presentation, please post them in the chat and we'll return to them afterwards. Today with me here are my colleague Abresh Uikani from Fraunhofer CML. Abresh has a bachelor's degree in media informatics and a master's degree in digital reality. He's been working now for about 2 years at Fraunhofer CML. He is a scientific researcher and a software developer. Then we have Michael Mangaard from Novia University of Applied Sciences. He has a master's degree in process and system engineering, has 10 years plus of experience in research, and is now for about 2 years project manager at Novia University. He has expertise in virtual assemblers and maritime digital twins. He's our guest here today since we have a cooperation between Novia University of Applied Sciences and Fraunhofer CML and the framework of FIP-S2 at Novia, our Fraunhofer innovation platform. Like I already said, this is part 2 of about our remote pilotage mini-series. If you have missed last week's presentation from Hans-Christoph Burmeister, where he introduced the whole concept, I want to give a very brief summary of what we saw last week. So our approach about remote pilotage is not making about pilotage obsolete and also not pilots obsolete. We just think it could be a safer way to enter a ship in a virtual way and assist the onboard crew that way. The main objectives and motivation are operational safety and also sustainability. But enough about last week. If you're interested in last week's session, you can find it in the MIU archives or the homepage of Fraunhofer CML. Today, we want to learn about the technical approach. How can remote pilotage be implemented? What is necessary to use it? And for that, we have our experts, Abresh and Michael. Abresh, how does it feel to use what you've developed in the lab on a computer on a real vessel and see what it looks like in real life?
Well, it's definitely something else because you actually see in a real environment what you imagined only beforehand. And now you have like real data. But to show you more on how and what we exactly did, I created a video for you. And here I will shortly present the overall infrastructure of our project. Yeah, right now it's called Repo Man Remote Pilotage, and this is our setup on the ship side and overall. So for people here who know the project of Fernsams or Multratag, we have basically the same infrastructure on the ship side, only improved for our use case. So we have a 360-degree camera installed onto a ship. We are grabbing all the ship's information, on all the chart information from the ship, and also the sensor information, and we are sending it over to the land side via 5G network or like mobile connection. On the shore side, we have a computer who's fetching all the data, and the VR headset which is displaying the 360-degree video and all the ship information and the sensor information. While the person on the shore side is in the VR headset, he's in a continuous communication with the captain on the board, who has the AR glasses on. And they're steadily communicating, and the VR person can basically highlight certain elements in the environment, and the ship's captain, the person on the board, can see these elements. Yeah, so I will continue the video so that you can better see what I'm actually talking about, because all these words can be quite difficult to understand. Yeah, this would be the shore side. And over here, Mikael could add something.
Yeah, here you can see the shoreside pilot view. So in the background, you see a 360 view of the camera stream coming from the ship. Currently, we have 2 360 cameras on board that stream both streams to shore, and so they are viewed in the background. And in front of you now, you see the virtual sea chart view that the pilot has. So basically he sees real sea charts, location of his own ship and other ships through streaming AIS data. The key feature we worked on this is how basically convey information from the pilot to the captain on board in non-verbal ways, or combined verbal and visual ways. So here you can add markers, paths, danger areas, and other highlighted areas in the chart. And while the pilot is updating, adding markers to the chart, it gets updated then on the captain's side on ship also in real time. Good. And then we also have a hand display. Now you don't see it, but we also have a mini-map display for the hand. So basically, if you want to close down the large chart so it doesn't obscure a view, you still have access it through this hand menu. That's now visible.
And like you can see here, it's all working over hand recognition and voice and gestures. So no controllers, nothing. So here you can see me on the ship's bridge with the AR glasses on, and I can show you what it looks on the ship's side. So basically here, this is the headset I'm having on. It's a HoloLens 2 in this case, and I can see it's like bigger glasses. Basically, I can see my whole environment, but also information augmented onto the glasses. So in this case, I can see ship's information, which we grabbed from the ship's data. And let's zoom in a little bit. Only for this frame, I could talk like about 1 hour. So what we've did there, but basically we grab the information, display it all around in the circle, all the necessary information. As you can see over there, there is this little small dot over there. It's a sailing boat. This is the ship I'm currently looking at. If the ship is far away, the circle gets bigger. If it's closer, the circle gets narrower. And basically, it's just like also in foggy weather, display ship's information, and also the person on land can focus on certain ships, and you get like visual cues that you have to look at this ship and put your attention in that direction. So we have also in here, we have waypoints and these markers Mikael talked before, and also to basically narrow down the visual information and not to get overwhelmed by all this augmented information, you can activate and deactivate layers. So that means I can deactivate all the ships around me, all the markers around me, all the waypoints around me, and only focus on the information which is important. Right now, there's a lighthouse. So the person on the land side tried to mark the lighthouse. And this is exactly how close it got in the AR application. So it's pretty like 10 meters. It's pretty close and pretty good in that regard. So
good. And there are also a lot of other features that you now don't see in this video. For example, we have implemented, since the pilot basically sees the same thing as the captain, since he has the 360 camera view. He can, for example, point in directions. Things that could be hard to do only with, for example, a voice communication. Say that look over there. Now he can point in that direction, and the pilot's augmented reality would basically could be pointing that now the pilot is pointing in that direction and talking to you. So these a lot of these small features are also implemented that you don't see here.
But of course, also like a main feature, as always, is the communication. So we always have a stable communication between both partners, and the visual cues are just trying to add more features like one would have, let's say, in real life, when the person is standing right next to you and showing in a direction, or trying to focus your sight on something. Over here, we have a small clip of the pilot vessel disengaging, and just like a comparison in the different views, how it would look like. And also over here, part of comparing different tracking methods. So because this is like the left one, the big blue dot is calculation of latitude and longitude into this 3D world, which the HoloLens is referring to. And the red square is basically distance and heading of the ship. So we just wanted to get as close as possible in the tracking as we could. Yeah, and this was it for the video. So next slide.
Yes, and of course the real application is about showing how we can do remote pilotage, more interactive ways between shore and ship. But for testing and developing, it's not. Of course, it's essential that you test things on ship in the end. But during the work process, it's not convenient to have to bring all your equipment on board, be on a 1 week cruise to Germany and back, or to Finland and back, in order to test that things work. So we have also set up this simulated testing environment to test the VR part of this solution. So basically here we are swapping out the ship with a simulated onboard environment. So we have a simulation with with one 360 camera, or essentially two 170-degree cameras on it. It streams the video from the simulation in exactly the same way as from the real ship to shore. And same thing with all navigational data, it gets transferred in the same way with the same protocols as you would do it between the real ship and the onshore pilotage. The only thing we cannot do in this testing setup is to test the HoloLens, since we don't have a ship bridge environment to test in. So there we have replaced it with a tablet application view. But otherwise it works in the same way. The pilot can be working in the virtual chart view. If he puts a marker on it, it gets updated immediately on the tablet chart that the captain has. So this way we can test these quick things if you want to check, is this menu easy to understand? Is it intuitive how you use this tool? We can give it to someone, test it, and get immediate feedback without having to put equipment on board the ship. But I want to stress that this, of course, does not replace things that you need to test things on site. This is just to make the workflow easier, make the prototyping faster, and basically to ensure that what we then put on the ship is in as good condition as possible as it can be, and that we can set up the test on ship as fast as possible.
And just to add to that, we had a discussion yesterday on that same part. Sometimes onboard testing is necessary under real circumstances, because in AR, I had like a talk on Monday with one of the doctors from Berlin, and we were talking about AR augmentation, and in the automotive industry, they tend to do that all testing in the simulator and then deploy the real product in the end when they are done. So not while testing. And the problem there was, on the paper it looked great, in the simulator the augmentation of the dashboard were great, in the real life not. And what they forgot is that for AR in that case, you need to focus on things in front of you, depth perception basically. Because in the simulator you're looking at a 2D screen. In the real environment you have like objects like ships which are 1 or 2 sea miles away, and your charts and your interaction and your UI, which is in front of you. So in this case, I also had all the ship's information, let's say 50 centimeters in front of me, and then the ship behind there. And then it was really, really not that great to change your focus between the different objects. And just through the through the onboard testing, I could see that it would be better to put the UI 5 or 10 meters away and just scale it bigger, so that the focus is easier to change between the different objects. So what's next in the pipeline? Essentially, what we want to achieve for the pilot on the land side is that he has the same situational awareness as he would have on the ship. It's not always possible. We also know it, like for everybody who's using Teams, it's something else to have a meeting over Teams or to have a meeting in person. What I referred also to last week on Christoph's presentation was that pilots were afraid that they couldn't see the little cues they would get while standing next to the pilot. So is he nervous, or how is the team looking? Are they all relaxed? Are they chilled? Is there a harmony on the ship's deck? And this is something we can't really bring over our current setup, but we are trying to get as close as possible by integrating an avatar system. So it could be like, yeah, from too comically to extremely hyper realistic, but we need to move our way forward definitely in that direction. And also another add-on would be like contour lines of shores and islands, just for the sake of when there is fog, that just to augment like the actual sight of the persons on the board. And of course, the Starlink system, something like Starlink, we have satellite, but we need a really fast connection onto the ship's deck, because there's a lot of data going in between both access points, and satellite is not enough for that. And of course, there are like cities like Kiel who are working on the 5G network in the harbor. This must also be then realized by more harbors. Yeah. So next on, yeah, in less than 2 weeks, I'm also at the ICMAS in Rotterdam. There you can also read about our current remote pilotage project, but on the ICMAS you can also test out the AR headset and how the interactivity is. And I have built a little project in there where you can also see ship's information and basically just interact and look and see how it feels. That's about it.
Thank you so much. Thank you, Albrecht. Thank you, Michael. Thank you for giving us a little insight in your work, even was it just a quick overview on what you're doing. Ali, there were some questions in the chat. You already started talking about it. So internet connection and data bandwidth. There was a question from Philip Durr. Thank you for that. It was aiming on 5G. So you already mentioned that 5G, is it sufficient or not? And you mentioned Starlink. So is there anything to add on that field? How do you gonna transport all the data that you have?
Well, for basic ships information and ship data, that's okay. But when we are talking about the 4K video, there are some limitations definitely there, because like even if you have a 4K video in 360 degrees, you are just looking like at a certain aspect in that video, and it's not that high quality, not that much. So that means in the end we need something like 8K videos. We have also setups where we have 2 cameras combined, 180 degrees in each direction, and each of these cameras has basically I think 6K video. And right now we are just fetching the video physically from the board to do our tests, but there must be some kind of a higher, a better internet connection, because the data is just getting too big, and it's just like a trade-off. If how big is the data and what kind of nice quality do you want to have? You can always like lower down your expectations and get like a lower resolution video, but we're trying to get the best out of the system.
Working on some compromises. Okay, I hope that answers the question. Thank you, Albrecht. There were also 2 questions. One was coming from Ralf Plump and the other one from Jens Hansen, and they're aiming in the both directions. So I'm going to summarize these 2 questions and direct them at you, Michael. So it's about sensor fusion. So one question is straightforward. What sensors are you using and where is the signal coming from? So is it ARS or radar? And the other question is about improving what you see on camera and improving the position. So there is an example given on radar-based traffic control. Is it planned to introduce this information and even merge more sensors to get a better overview and get more precise information?
Yeah, absolutely. Currently, we are streaming AIS data and the 360 camera. Radar is, of course, one thing that would be really interesting, but then you also would need to have it in a useful format to do the sensor fusion. I think sensor fusion has been one of my big research interests, and it's definitely something we want to do. And in a sense, Ari is already doing it in the augmented reality with video and AIS is trying to match the video with the AIS coordinate, for example, and that's one form of sensor fusion. But putting radar into it, improving the accuracy of AIS data with radar and with other things. It's definitely on the to-do list, but it's not now implemented in this first minimum viable product that we've been working on.
But right now we have, like, on the ship, it's called kind of a multiplexer, which we just can plug into the system of the ship, and we get the AIS data out of there. But I heard also from a lot of pilots that AIS data is not the data you should rely on in dangerous situations. So yeah, we are still trying to get the radar in there somewhere, because I think every pilot I talked to was saying radar is one of the most important things. But we are on our way there, definitely.
Yeah, and
Okay.
the issue with radar definitely has been to get the useful format out. Screen grab of a radar is not that useful for sensor fusion. It's useful for showing something to a pilot, but if you really want to use the data, it's not the usual format that we need.
Thank you so much. So there are more questions coming in the chat. So I'm not sure, our time is over here. So yeah, maybe Michael and Albrecht, you could reach out to the guys asking these questions. We can also do it the other way around. The email addresses are here. We're more than happy to discuss in further detail and present more on what we have. But for today, our time is over. Thank you to Michael and Albrecht once again. And then next week, my colleague Christian Wick will be presenting his project Agency. It's about automatic model generation and cyber-physical systems. If you are as curious as I am what exactly that is and what he's doing there, you should definitely not miss it. And I hope to see you here again next week. Have a nice weekend.